Okay, so you are welcome to our tutorial set on ordinary differential equations. Um, we want to look at a few of the subjective questions. Um, we have two questions here. Uh, One of them is a mixing problem. The other one is a molecular problem. Anyway, all of them are under chemistry. Molecular reactions. Yeah. So we'll look at the first one. Which reads like initially 50 pounds of salt dissolved in a large tank having 300 gallons of water. So as we read, we will write out 50 pounds of salt initially. So that simply means that uh, our at t equal to 0, um, the amount of substance is also equal to what? 50, like this. And then the volume of water is equal to 300. A brine solution is pumped into the tank at a rate of 3 gallons. Okay, so inflow rate is equals to 3 gallons per minute. Okay, and now and a well mixed solution is pumped out at the same rate. So outflow rate equals to 3 gallons per minute. And now if the concentration of the solution entering is, so concentration in is equals to 2 lb per gallon. Find the amount of salt in the tank at any time t. So these are our basic informations, but we know that the IVP that will be modeling, of course this IVP is very important in solving this. So we will have the A, the T to be equals to R in minus R out. Okay, and then our A of 0 equals to what is given here, that's 50. Okay, so now let's look for our R in. So our R in goes to inflow times concentration in. The inflow was given to be 3, so 3 times the concentration in, which is 2, that's just 6. Now R out, we don't know what it is. We know the outflow, because the outflow is 3, so this outflow times C out is just 3 times. Now the amount of substance, so the C out is equals to A over V plus change in the rate times T. And so this is just A all over the volume that was given is 300. So 300 plus the change in rate, the rate in minus the rate out, rate in 3 minus out 3 times T, and this is equals to A all over 300, because this one will go to 0. Now this will imply that we have here to be A all over 300, and this is just 3A over 300. So right now I can formally write our IVP to be the A, the T to be equals to R in 6 minus the R out is this 3A all over 300, and then our A of 0 is equals to 50. So this one you get some marks for that, so take note if you do this ODE. So we have a differential equation which we have to solve. So dA dt is equals to 6 minus 3a all over 300. So we can write this as dA dt plus 3 over 300 a equals to 6, like this. And this is a first order differential equation, and we can solve using in fact we can reduce this. We have dA dt equals to plus 1 over 100a equals to 6, which we can solve using integrating factor. So our integration factor u of t is equals to e power, this is our p of t, 1 over integral of 1 over 100 dt, and then just e power 1 over 100 t. This is our integration factor. So our e of t will be equals to integral of our q of t, that is just 6 times our integration factor e power 1 over 100 t plus c all over the integration factor 1 over 100 times t. Now doing this, we just have 6. Integrating this, that will just be times 100 over 1 e power 1 over 100 t plus c all over e power 100 e power 1 over 100 t. And so dividing through, just have 600 plus c e power negative 1 over 100 t, like this. So this is our a of t. So we have to find our c using the IVP. So at t equals to 0, a is equals to 50. So we do that substitution. So a of 0 is equals to 600 plus c e power negative 1 over 100 times 0. All this is equals to 50. And this will imply that I have 600 plus c e power 0 equals to 50. So c is equals to 50 minus 600, and this equals to 550 negative of that. So therefore our a of t is equals to 600 minus 550 e power negative 1 over 100 t. This is our a of t. So the second question is, how much salt is present after 15 minutes? So that's the b. T at t equals to 50. So we have a of 50 equal to 600 minus 550 e power 1 over 100 to brackets 50. Putting this in your calculator, you get, I think you get 266.4081 pounds or so. Yeah. How much salt is present in the tank after a long time? That's the C. So that simply means we take the limit as t goes infinity. It means as t, the time goes higher and higher, or we go for a long time, what will be the amount of substance. So we take limit t goes to infinity of a of t, but we know that a of t is what we have here as t goes infinity of 600 minus 550 e power negative 1 over 100 t. So as this goes to 0, we just have the limit as t goes to infinity of 600 minus 550 over e power how 1 over 100 t. Sorry. Okay. So as this t goes to infinity, or it becomes big, the whole of this term will go to 0. This thing will become very big, so the whole term will go to 0. And the limit of a constant is a constant, so we have 600 pounds. So after a long time, our amount of substance present will be 600 pounds. That's all for the first one. Okay, so let's look at the question 2 of our solutions to some questions on ordinary differential equations. So here it is a problem in chemistry, but it is a chemical reaction problem. And then it reads like, suppose that one molecule of A combine with one molecule of B to form one molecule of C. Assume that at the outset the concentration of A is 5 moles per liter and that of B is 6 moles per liter, and that of C is 0. After 1 second, the concentration of C is 0.5 moles per liter. Okay, so we are required to do this one. So the first thing we have to write is to write the reaction. So they said we have two substances combine to form a third one. So we have so the reaction we have A plus B going to C like this. But then they said something that 1 mole of B combines with 1 mole of 1 mole of A combines with 1 mole of B to form 1 mole of C. Assume that at the outset, and so here we know that since the formation of C requires 1 mole of A, then the concentration of B, or we can even see that let small a, small b, and small c be the concentrations of the substances A, B, and then C, like this. So here we know that since at the outset we know that they require 1 mole of A to form 1 mole of C, then the concentration of A, the concentration of the A was equals to 5 moles, okay, and that of the B is equals to 6. So each concentration, because this 5 is used in forming C, okay, or after forming C, we realize that the moles per liter that is used is 5. So the concentration of C is now 5 minus C, of A is now 5 minus C, and that of B is just 6 minus C, okay. So we have these two things, but by mass action, we know that their product, we can model the equation using their product. So we say that dC dt is equals to K, then the product of this and this, that's just 5 minus C and 6 minus C, like this, okay. So and then they said and that of C is 0. So for C, okay, so C of 0 is equals to 0, like this. So this is our IVP, which we are required to solve this, okay. So this is what is modeling our problem. So we have to solve this one now. So we have dc dt equals to k 5 minus c 6 minus c. So this is separable. So since this is separable, we'll have dc over 5 minus c 6 minus c equals to k dt. So we solve this one, and what approach will we use to solve this one? For this one here, you can use partial fraction disintegration. So I'm going to express it in terms of partial fractions. So that will just be 1 over 5 minus c 6 minus c equivalent to a over 5 minus c plus b over 5 minus c. Okay, yeah, that's 6 minus c. And so doing this, we just have 1 to be equals to a into bracket 6 minus c plus b into brackets 5 minus c, and so 1 will just be equals to 6a minus ac plus 5b minus bc. Okay, so we do comparison. These are constants, these are the constants. Remember, this c is a variable here. So we just have even here we could have said that use the cover up rule. Say that if c is 6, so if c is 6, that just implies that we have 1 equals to a times 0 plus b brackets negative 1. So b will just be negative 1. And now if c is equals to 5, that will imply have 1 to be equals to a into bracket 6 minus 5 plus b of 0. So this will imply have a to be equals to 1. Okay, so then we can then write our integral of 1 over 5 minus c 6 minus c dc equals to k dt. So this one is rather integral of the a is 1, so 1 over 5 minus c plus is the c integral of 1 over minus, this is minus because the b is negative. So that's just 6 minus c, this equals to k dt. So integrating this one, if we differentiate it down here, get negative. So we have to introduce negative here, but we have to cancel it. So if I put negative here, then negative will be here. Okay, so I'll get negative ln 5 minus c like this, and then same thing here, so minus so then I put negative, then ln of 6 minus c like this equals to, here I'll get k t plus, since we have k here and c inside, our constant of integration will just be t. So we have this, but here and here will make it positive. So I just have ln of 6 minus c over 5 minus c like this equals to k t plus d. You take e of both sides, so that will just be 6 minus c over 5 minus c equals to e power k t plus d like this. But we have to find they are saying that after 1 second the concentration, we we've not applied the IVP, so let's apply the IVP before this one. So C of 0 is equals to 0. Okay, so that will just be 6 minus 0 over 5 minus 0 equals to e power k times 0 plus t, and so that will just be 6 over 5 equals to e power d. Taking ln, so our d will just be equals to ln 6 over 5, like this, and then this one is approximately equals to, let me see, ln of that, so ln 5 over 6 over 5, that's just 0.182321. Okay, so right now we can write this as 6 minus c over 5 minus c equals to e power our d. Okay, so that's just kt plus 0.182321. Now we need to use the condition c of 1 equals to 0.5 to find k. Okay, and so we have 6 minus 0.5 all over 5 minus 0.5 equals to e power k times 1 plus 0.182321. And so if we do the arithmetic here, we get 5.5 over 4.5 equals to e power k times e power 0. Okay, let me just make it, because here it was just ln of this, so I can just put that 10 there, and then let me erase this and put that one there. So that's just ln 6 over 5. So this and this will cancel each other, so we'll get 5.5 over 4.5 equals to 6 over 5 e power k. So doing the arithmetic here, so I'll just get 5 over 6 into brackets 5.5 over 4.5 equals to e power k, like this. So my k is equals to ln of this 5 over 6 brackets 5.5 over 4.5. So this 4.5, close this. So that's just 0.0.01834913867 going. So we have this as our key. So therefore we can write this as 6 minus c all over 5 minus c equals to e power. This is the key. Okay, this is the key. So let me see 5.5 divided by 4.5, 11 over 9 times 5 over 6, over 6, 55 over 4. So ln 55 over 54, like this and this. So times the t, plus the ln 5 over 6, or this 6 over 5, or this 6, 6 over 5, 6 over 5, 6 over 5, but that is fine, which is just 6 minus c over 5 minus c equals to 55 over 54t plus 5 over 6 or so. I think we now have this Yeah, we now have this, but yeah, I think I can leave it this way, or we can go further. They are saying that find the formula for the concentration C of T. So here you can just make C the subject. You can make C the subject. Then they are saying that how long does it take for the concentration of C to reach 3 mole per liter? So um at at T equals to what? With C equals to 3. That's the question. So that's just simple to do. So I'll just have 6 minus 3 over 5 minus 3 equals to 55 over 54 T plus 5 over 6. And so here just 3 over 2 minus 5 over 6 equals to 55 over 54 T. And then yeah, just 3 9 over 6 minus 5 over 6 and 55 over 54. And so here is just 4 over 6 equals to 55 over 54 T. And so T is just equals to 4 over 6 times 54 over 55. And this is equals to 1 man. And so that's just 36 over 55. So you get some 0 point something. Okay, so this is the answer, seconds. What will be the concentration of C when the reaction is complete? The concentration of C when the reaction is complete. So it simply means that you take the limit as C of T goes to infinity. So that would have mean that I'll have 6 minus C all over 5 minus C equals to 55 over 54, 55 over 54 T plus 5 over 6. I just make something the subject here. That will just have 6 minus C equal to, so this one multiplying by 6, 54 equals to so you just make C the subject here and take the limit as it goes to infinity, 0 T all over 5 4 minus 3 3 0 T. Now we take the limit, so limit as T goes to infinity of C of T, and so that will mean that this term will go to 0, this term will go to 0. So we will simply have 1650 divided by 330. So that will be 1650 divided by 330. So that's just equals to 5. So 5 watt, 5 moles per liter. Yeah, per liter. So this is the answer as that's the answer when the reaction will be complete. So this is how we find it. There's a simpler way of doing this without doing this all these expansions, but if you do the expansions too, you are not wrong. Okay. So we can do this one too. Okay.